Happy learning,
Okay.
everyone.
Hello, everyone. I hope all of you are doing good. Okay, so we'll wait for a couple of more minutes as more people join in. So, what did we do in the last session? We completed regression, right? Yes, we did regression. So, today we are going to do more interesting models, starting with association rules, and then we'll do PCA, and then we'll do we'll start with naive Bayes. Let's see if we can do naive Bayes, and this basically we'll start with classification. Okay, in the meantime, let me open these. We're going to start with association rules, and before that, I hope all of you can see my screen. So we'll start with, I think we left with interaction variables, right? So I'll introduce you to the concept of interaction variables. And then we'll start with association rules, principal component. We'll just start in 2 minutes. Am I audible to all of you? Am I audible to all of you? Okay. Okay, as mentioned, please do not share any personal contact or personal information in this group, right? Because this the recordings happen, and the that recording is like accessible to many, right? So please do not share any such personal information. Okay. Okay, so last thing that was left with regression was interaction variables. Sometimes what happens is in regression an interaction effect exists when the effect of an independent variable on dependent variable changes depending on the value of one or more independent variable. Means sometimes you'll see interaction variables in the form of x1 and like x1 x2, right? X1 is one variable, x2 is one variable, but the dependent variable is also it gets impacted by the interaction effect between the two variables, right? So this is called interaction. And like here you can see there is no interaction, right? In this equation you can see there is an interaction between x1 and x2, and in this you can see there are interaction between even triplet, 3x 3x variables, right? So this is called interaction variables, and it is represented by the multiplication. We show it as a multiplication of the two variables, right? And these are like higher order, because you can see this is to the order of 1, this is to the order of 1, but this is the order of 2, right? So higher interactions are usually higher order interactions, and um, like two-way interaction, three-way interaction, they can also be catered within the regression equation, right? So this is just a concept you should be aware of, that there can be interaction variables also, right? So on that note, we will close this, and now we are going to do a very interesting model called association rules. Have you heard of association rules? Anyone? Anyone who has heard of association rules? No one? Okay. Anyone who has heard of market basket analysis? No one has heard of market basket analysis? Yes, Alok, you're right. They are the same. You're right. They are almost the same, right? Okay. So, I mean, you can say market basket analysis is one of the use case of association rules. There can be many, but market basket is one of the use case of association rules, right? Okay, so let's understand association rules algorithm. Okay, before we understand what are association rules, let me ask you a question. Okay, forget this. All of you would have gone sometime to a superstore or maybe a hypermarkets, right? Big supermarkets which hold lot of household products, right? Every category of household products you can buy under the same head, right? Under the same roof. Yes, yes, or maybe grocery stores. You must have gone through. I mean, gone to grocery stores also, right? So when you go to such store, you see the placement of the products that are there, right? Do you think these products are kept randomly? Do you think these products are just kept randomly? Okay, the way they are just uh, brought out or from the truck or from the lorry, right? No, right? All of you agree? They are not randomly kept. They are kept with some scientific uh, thought at the behind. And what is that scientific? Um, you can say, what is the thought behind it? The thought behind this is to maximize sales, and then keeping that thing in mind, they are kept. The products that are kept aside are chosen scientifically, right? And how are they chosen scientifically? Using the association rules algorithm, right? With the intent, as I said, the intent is to maximize the sales, right? The intent is to maximize the sales, and that is why they and association rules algorithm helps stores like retail stores and hypermarkets, supermarkets to understand what are the products that are bought together. What are the products that are bought together in that particular store by analyzing the historical transactions? Okay, by analyzing the historical transaction, it helps in understanding what are the products that are bought together. Okay, next, it its use cases not only, and this understanding the product that are bought together in a retail store, right? This is known as, and which what is the combination of products that the customers are really interested in buying. For example, bread and butter, right? Let's assume that they are usually bought together. Milk and butter, bread and milk, right? Maybe let's say meat or chicken and some barbecue sauce, right? So such are the products. We also know these are very common combinations, but when you study the historical patterns of thousands and millions of transactions that have happened, you come up with some really astonishing combination which you would have even never thought of, right? So that's the power of association rules, and association rules help you understand the uh, such combinations and help you and help grocery stores or help superstores to keep those. I mean, what then when you know that these two products are bought, I mean, there is a high frequency that bread and butter are bought together, right? So the tendency of these superstore markets, hyper stores, is to keep them as near as possible so that the customer do not have to search for those, and this really impacts, this really boosts their sales. Is that clear? And this basket of products that you see that are bought together, we call it market basket analysis. Okay. Now another use case of association rules is when um, you all of you would have shopped on Amazon, right? Or any other e-commerce website, right? So when you buy a product or when you have even put a product in your cart, it starts recommending people. Those who bought this also bought this. People bought this together. Sometimes it automatically gives you a combo at a very good price, right? So basically these are prompts, right? They're It's prompting you, right? That okay, historically people those who have bought, and it is also done by scientifically by analyzing the historical transactions. So that recommender system that is built in websites like Amazon, Flipkart, and the likes, right? That is also based on association rules. Is that clear? The introduction part is clear. What is association rules, right? So let me discuss a very interesting case. Uh, how many of you know this beer diaper syndrome? Anyone who knows beer diaper syndrome? No one? Okay, then this is going to be really interesting discussion, and I would encourage all of you to maybe go. I mean, of course, it's there all over the web. Also, you can go and maybe read more details about it, right? So, and this is a real story, right? Sometimes I think in early 20s, no, early I think somewhere around 2010. I don't remember, or maybe before that. I'm forgetting the year. All of you know Walmart, right? Walmart, of course, based on the data mining they used to do, they observed a very typical pattern that on Friday evenings, beer, the sale of beer and diapers used to shot up. Do you find any logical connection in these two? If I have not tell you this story, I tell you, okay, beer and diaper, keep them together because they will be bought together. Do you find any logical connection? No, right? On the face, it does not look like any logical reason why beer and diaper would be kept together, right? But what happened was, I mean, when this incident happened, Walmart discovered through data mining that the sales of diaper and beer were correlated on Friday nights, Friday evenings, right? It further started digging the data and the reasons thereof. And what came out, and to their shock and astonishment, that the correlation was based on working men who had been asked to pick up diapers on their way home for work. Now, Friday evening, it's like a weekend, right? Weekend starts, so most of the working class they used to. I mean, they would probably just uh, relax and maybe have some party on evening, right? So, of course, men, those who would come from office, they would pick up uh, beer, right? And the women, they just wanted to be free and carefree, and like they should, I mean, maybe let the child also be, I mean, they should take a break from keeping the child, right? They would want the men to pick up diapers so that they can just make the diaper, I mean, make the child wear diaper, and then they can maybe enjoy the evening, right? And this was a trend. It was such a, I mean, as I said, it was such a very strange observation. And when this they found that in a particular region this is happening, right? What they did, they started keeping beer and diaper together in their stores. And by moving these two items closer together, Walmart reportedly saw the sales of both the items increase geometrically. I mean, just think beer and diapers are kept together. I mean, logically, there is no connect. It does not, I mean, nobody can find a logic. But, and not only this, it was just one store when they tried, or one area. They replicated the same thing in various other regions and areas, and everywhere they were able to successfully increase the sales of the two products. Isn't this a very interesting, uh, I mean, story you can say, or a very interesting phenomena, right? So this is just one of the interesting phenomena. You can find many other stories on the web, but yeah, beer diaper is one of the most famous Because prior to this, nobody would have thought a logical reason why they both would be bought together. Is that clear? So that is why after this it was known as beer diaper syndrome. Is that clear? Beer diaper syndrome is clear? Interesting. Did you find this interesting? Yes. Okay. You may want to read it at later, right? So let's understand what is association rules. Association rules mining in an algorithm finds interesting associations and relationship among large sets of data items brought together. This rule shows how frequently an item set occurs in a transaction. A typical example is a market basket analysis. So this is market basket analysis is one application you can say of association rules. Okay. The application of association rule mining are found in marketing, market basket analysis in retail, clustering and classification, and of course now e-commerce, right? So market basket and in market basket analysis, which is a key technique used by large retailers like Amazon, Flipkart, Sainsbury, etc., to analyze customer buying habits by finding associations between the different items that customer places in their shopping baskets, right? The customers place in their shopping baskets. Okay. The discovery of these associations can help retailers develop marketing strategies by gaining insights into which items are frequently purchased together by the customers. Is that clear? What is association rules? Right? Now, this association rules algorithm is uh, this association rules is done through a priori algorithm, right? It is done through a priori algorithm, right? A priori algorithm was given by R. Agarwal and R. Shrikant in 94 for finding frequent item sets in a data set for Boolean association rule. Okay. Name of the algorithm is a priori because it uses historical data or prior knowledge of frequent item set properties. It builds on associations and correlations between the item sets. It is the algorithm behind you may also like. So you may also like. I'm sure these four words are sounding familiar to all of you. You may also like dash dash this, right? Yes, where you commonly saw in recommendation platforms, right? Yes. Okay. It tries to answer the below questions. How can you find frequent item set in a data set? First, how can you find frequent item set in a data set efficiently? Right? So first is how can you find the frequently bought item sets, and then how can you find these frequently item set in a data more efficiently? Okay, so this association rules, when we are going to run this A rules a priori algorithm, it will come up with three important metrics which we are going to learn now: support, confidence, and lift. Okay, so let's understand what is support, confidence, and lift. Okay, so support of any product A, let's say product A is there, bread, right? The support of any product A is simply the number of transactions that happened for A divided by total number of transactions for any grocery store or any superstore. Is that clear? Support of transaction, support of A is simply transactions of A divided by total number of transactions. Any confusion? Pretty simple. Okay. Frequency. Now, it is the frequency of occurrence of an item or an item set in the transaction. Now, item means single item. An item set means even a combination of item. For example, I want to know what is the support of bread and butter bought together. So simply transactions in which bread and butter are bought divided by total number of transactions. So that is called item set. Clear? It is the default popularity of an item or item set. It is the default popularity of item or item set. It, doesn't it give you the popularity? How popular is the product? Yes? Yes? In mathematical terms, the support of item X is nothing but the ratio of transactions involving X to total number of transactions, which I have already discussed. So support is clear to all of you? What is support of any product? Any questions? Let me know. No question? Okay. Next, confidence. Now, confidence of in confidence, right? Confidence measures how likely an item Y is purchased when item X is also purchased. So let me give you an example. If suppose there are 100 transactions of bread, very simple example that you can, I mean, just relate it right now. If suppose there are 100 transactions in which bread was bought, right, and 30 transactions were where bread and butter were bought together, right? And total number of transactions on that day, that particular day was 500. Total transactions 500, 100 transactions in which bread was bought and 30 transactions in which bread and butter was bought. Let me write it. Total transactions on the day is 500. Transactions for bread 100 and bread plus butter is equal to 30. Okay. Now, can you tell me, first of all, what is the support of bread? What is the support of bread? No one else? Only Alok replied. Okay. Others? Did you not understand? Okay. So I've got 3 responses, but yes, all of you are right. Right? Support of bread is simply 100 upon 500. Right? Now let me ask you, what is the confidence of bread and butter? We write it like this: bread to butter. Right? It means what is the likelihood that a customer will buy butter and bread together? Very good, Idris. Correct, Alok. You are also right. Right? All of you are getting this? Simply transactions involving both divided by transactions involving X, bread and butter. Clear? Confidence measures how likely an item Y is purchased when item X is purchased. So how likely there are chances that butter will be bought when a customer has bought bread. 30% chances that the butter will also be bought. That is called confidence. Clear? And very logical also. You are 30% confident that if someone is buying bread, he will buy butter. Right? Logical also. Right? Let's look at the third metric. Lift. Lift is the factor by which the co-occurrence of X and Y exceeds the expected probability of X and Y co-occurring had they been independent. Means, so it is written as lift of X to Y. Means, what is the factor by which the sales have jumped because X and Y were bought together compared to had they been independent products and there was no um, association between them. Okay, are you getting it? So lift of X to Y is simply confidence of XY divided by support of Y. So what is confidence of X and Y? Transactions involving both X and Y divided by transactions of X, right? Or support of X, right? So no, sorry, transactions of X, right? So if you see this, confidence of XY divided by support of Y. Okay? And lift is the ratio of confidence to support, right? Lift is the ratio of confidence to support. Lift, if lift is less than 1, it means X and Y are negatively correlated, means if X is bought, Y is not bought. If lift is greater than 1, they are positively correlated, means as X is picked up, Y also gets picked up, right? And if lift is equal to 1, the products are not correlated at all. Clear? Okay. So let's take a look at this example. Given the set of transactions, find the rules that predict the occurrence of an item based on the occurrence of other items. Okay. So what you have to tell me is, first, what is the support of, okay, look at the transactions. There are 8 transactions. Just take a closer look. Okay. Now tell me, what is the support of Apple? 4 by 8? Okay, let me ask you one more question. What is the support of beer? 6 by 8, right? Great. What is the confidence? What is the confidence that of Apple to beer? What is the confidence of Apple to beer? Okay, I'm getting interesting responses. 3 by 6. Okay. Any more? Apple to beer. 4 by 6. How come 4 by 6? Okay, got it. Okay, okay. I think none of exactly. I got one correct answer. That is 3 by 4. Let's see. I said confidence of Apple to beer means how much confident you are that beer will be picked up knowing that Apple was picked up. Understand it. Conditional probability, if you know it. What is the confidence, how confident you are that beer will be picked up knowing that Apple is already picked up? support of, everyone got it now? Right? Support of apple to bear. What is support of apple to bear together? It's 3 upon 8. Right? Support of apple to bear. It's an item set. Okay? 3 upon 8. 3 upon 8 divided by support of apple, which is 4 by 8. So 3 by 8 upon 4 by 8 comes to be 3 by 4. Okay? Clear? Now let's take a look at the last part, lift. Lift of apple to bear means, had they been bought independently, what is the percent by which the sales have picked up because they were bought together? And the formula is support of apple to bear upon support of apple. This becomes confidence of, see, this becomes confidence of apple to bear, right? Is this clear? So if you want to, and then divided by support of bear, right? So support of apple to bear is 3 upon 8 divided by support of apple 4 upon 8 divided by 6 upon 8, right? So what it comes out to be, who will calculate it for me? I think 1. It was, Alok, in the last slide I had mentioned confidence of XY, which is this only. That is what I was showing now. See, confidence of XY, right? Which is, if you split confidence of XY, it is this thing. Got it? Is that clear? Right? So I had just split it because, see, support is the most easy to understand, right? So if you, how much is the probability of to, what is the factor by which the products when bought together, what is the factor by which the sales increase had these products been bought individually, had they not been independent, right? This is the lift, right? What is lift is the factor by which the co-occurrence of X and Y exceeds the expected probability of X and Y co-occurring had they been independent, right? So simply the products for which you have to calculate lift, simply in the numerator calculate the support together and in the denominator calculate the support individually. Okay? Is that clear? So I think this comes to be 1. So as such, if you'll see, there is no impact, right? Correct? 3 upon 8 in the numerator and 4 upon 8 multiplied by 6 upon 8. Got it, Idris? Okay, great. Right? Okay. Clear? Now I want you to quickly do this. Do it. Maybe, okay, you want to read it, that's okay. Just read through this and tell me if it is fine. Support of milk to butter. Notice here, this is a combination of product, right? Or item set. I'll just be back in a minute. Let me get my water bottle. I forgot it, right? In the meantime, just go through these 3. Total 100 customers are there. Is this total 100 customers? Now this is in terms of customers, okay? Not in terms of, so 100 customers, 20 bought milk, right? So 100 customers is 100 customers on a particular day, let's say, right? So 100 transactions, you can take it as 100 transactions, okay? So support is clear to all of you? Type S if support is clear. Type S. Okay, next, confidence. Only two people support is clear to. Just two people. Okay, yes, thanks for the response. You always forget to respond, right? I have to push. Okay. Confidence of milk to butter. What is the confidence of milk to butter? What is the probability that butter is bought knowing that milk has already been bought? 12 upon 20. Type C if confidence is clear. Okay, then lift of milk to butter. I think this is wrong. You can just try it. Lift of milk to butter. It should be 0.12 in the numerator divided by. Okay, I think 2 has been striked off. It's correct, right? So it should be, let me write it. It should be like this. 0.12 divided by 0.16 multiplied by 0.2, right? So that's correct. 2 has been striked out. No, I think, no. So it should be, I can strike out 2 only. I should have striked out 4, right? So just calculate what should be it. I think 3.75. 3 by 4 or 0.15, I think. Whatever you can calculate. What is this? 3 upon 4 multiplied by 0.2. 3.75. Okay, fine. Everyone? So this is 3.75, not 7.5. Is this clear? One more example, quickly. Quickly, I want you to calculate the support of milk, diaper, and beer. I think 2 examples are good. Should we move or one more? You do it quickly then, right? Quickly. 1 minute only I'll give for 3 metrics. Quick. Support of milk, diaper, and beer. So milk, diaper, beer. Milk, diaper, beer. Milk, diaper, beer. 3 upon 5. Isn't, should be 3 upon 5? Milk, diaper, beer. Milk, diaper, beer. Milk, diaper, beer. 3 upon 5, right? Again, this is written 2 upon 5. It should be 3 upon 5. Correct? What is the answer? 3 upon 5 or 2 upon 5? No response you guys give. 3 upon 5. Okay. I think again there was some issue with this. Okay, fine. I got the response all of a sudden. Okay. Confidence of milk, diaper, and butter. So confidence of milk, diaper, and butter is total number of transactions of milk, diaper, and butter divided by number of transactions of milk and diaper. Now, this is actually, it should be milk and diaper leading to beer. right? So it should be, I'll correct this and then reshare this. It should be milk and diaper leading to beer. Okay. So in milk, diaper, beer transactions upon number of transactions of milk and diaper. Let's leave it. I think this example is also wrong. I mean, the calculations are wrong. I will correct it and share it, right? I'll correct this and share it. Okay? I don't think it should be. It's 2 by 5. Yeah, yeah. It should be 2 by 5, right? This is wrong. Yeah, yeah, yeah. It's wrong. Right? So, of course, you've got the logic, right? Don't go by this calculation. I don't know. I had corrected it, but maybe this old file has come up. Yeah, first, no, first is also 3 upon 5. First is 3 upon 5. Milk, diaper, beer. There are three transactions. Milk, diaper, beer. Milk, diaper, beer. Oh, 2 upon 5. Right. I was counting this as beer. Correct. It's 2 by 5. So this is correct. Yeah. Fine. I read it wrong. So it's 2 by 5. First is correct. Then second, okay, you got the essence, na? You got the essence, right? Okay, got it. So what we are going to do now is we'll go to R. Association rules. Now, for this association rules, I have, yeah, not data set is not required because we are going to work from the data set that comes with A rules package. Okay. So for this association rules, I want you to install this package A rules. Install the package A rules and activate this package. Okay, I think I have shared this read dot transactions. Okay, this file is there. Association rules a priori algorithm. I've shared this file. It should be there. Yeah, it's there. Association rules a priori algorithm. It's a CSV file. This one. Now, first, once you're done till line number 4, then let me know. Once you're done till 4, just let me know. Once you have installed and activated A rules package, please confirm. Only one has done. I will wait. At least 4 to 5 confirmation I get, then only I'll proceed. Can I get more confirmations? I'm sure many would have done it. Thank you. Okay, fine. Right? You got this message. Attaching package, loading package by matrix. That's okay. That's okay. Just check in the packages you have A rules. I don't think that should be an issue. Just check. Then it's okay. Fine. So even if I see, I'm also getting this loading package required matrix. This is fine, right? It's a message only. Yeah, yeah, fine, fine, fine. Okay. Now, I don't think we'll either you want to go with fixing the directory, or what you can do is read dot transaction file dot choose also you can do, right? But now I want you to observe, earlier we had done read dot CSV, read dot Excel, right? And read underscore Excel, and read dot table we have also done, right? We have done these earlier, but here, can you see this new command, read dot transaction? Yes, isn't this a new one? Isn't this a new one? We have not done read dot transactions earlier, right? Now why is this read dot transaction here? See, let me show you this file. This is a file. Can you see? This is a file. It has 9,835 transactions, right? And each transaction is in a single row. So first transaction, or you can say first customer came, Kamalpreet came. He bought citrus food, semi-finished bread, margarine, and ready soups. Pungodi came, tropical fruit, yogurt, coffee. Alok came, whole milk, and so on. Is that clear? Idris bought the fourth one, and so on. Right? So now, in when you do read.csv or read.table, right, the transactions are read column wise because you have headers. Remember, you have headers. Here you don't have any headers. These are just the transactions, the details of the transactions or the products that were bought together in a single bill or a single transaction. Is that clear? This data is read row wise. Each row is taken as one transaction. That is why it said read dot transaction. Right? I would suggest go with line number 18. Okay. Otherwise, you'll have to set the directory, get working directory, and all that thing you'll have to do, which can be avoided if you straight away do file dot choose. Now let me just read through this. Read dot transactions is used as a data is in transaction format, already discussed. It reads the data row wise. CSV, read.csv, reads the data column wise. Is that clear? So quickly, can you do read.transaction, file.choose, and next, once you have done it, I could not see the file. All of you got the file? Association rules file is not there. Okay, wait. You don't have that file. Strange. It's there. See, this is what I shared, now. I shared this only. Are you not having this? Don't you have these four? So what all do you have then? Okay, fine. I'll share it. But what all do you have? Strange. Wait. Okay, I uploaded it. Strange. Okay, I'll put it here. Hmm. Okay, okay. I sorry. I thought I put this. My bad. Wait, wait, wait. I'm sharing it. Okay. Don't. No, no, no. Why? You can always tell me. I mean, I'm also a human being. I can also do mistakes. In fact, everyone does it. So I also do it. Many time I do it. Yeah, yeah, I got it. I'm also kidding. But I can't say, no, I'm the trainer, so I can't do any mistake. I can't say that. Okay, now all of you got it? Yeah, yeah, that's just a warning message. You can ignore it. Warning messages you can ignore. Okay, now everyone, can you quickly import this file, name it as grocery underscore items? Yeah, I'll share the link. There you go. Once you're done till 18, let me know. Once you're done till 18, let me know. Okay, what about others? Only two? Okay, fine. So I'm assuming others have done. Now inspect head of groceries, right? If I write inspect head of groceries 50, it's going to give me the first 50 transactions. Okay. If I just write head of groceries 50, it will give you just the head of 50 transactions and out of this. Okay. Size. If I write size of head of 50, it's going to give you the number of items bought in first 50 transactions. Clear? Size of 50 is clear. Size of head of grocery item. Inspect tail will give you the last 50 items in the entire transactions, right? Once you're done till 34, let me know. 34 is done. Once you're done till 34, please let me know. Thirty-four is done. Okay, I assume 34 is done. Next, a priori. If you want to know more about a priori algorithm, question mark, a priori. It is algorithm that is used to create the support confidence lift measures in the data, right? Double question mark. It gives you the, let's say, within package. If you want some details of a small command, right? Then you put double equal to. Okay. Okay, Idris. Okay. So a priori algorithm we are going to apply. We are going to use a priori algorithm on this data set, and I am going to define some parameters, means boundaries of this. Parameters here means it defines the minimum value of support and confidence. Right? See, if I don't define parameters, my support confidence, I mean, there will be no limit to the combinations it can create. Even to a single last confidence, it's going to create that. But I don't want, do I really want to look at the longer tail? I would be interested in only top 10, 15, right? Or I can define that, okay, I am only interested where the support is of a product. I will only be interested in products which has support of 1%. Okay, means out of 9,800, please include only products with 98 or more transactions, which are there in 98 or more transactions. Got it? Did you get this? Also, include products with confidence of at least 50%. Else, I am not interested. Is that clear? That is what parameters are for. Okay. Am I? Are you okay with this? Line number 43, 44, 45. So, defines the minimum value. Do not select any item where the support or confidence is very low, right? So I would not be interested where support is 0.001 or confidence is like only 1%, right? So this is what I have defined the parameters. So I will run this and you'll see I get some output, right? Now, when I do a summary of this, summary of new grok is my model, name of the model. Please do it. Then I run the summary of this that will give you the actual support, confidence, and lift. So if I do a summary, line number 55, when you're done with summary, let me know. It gives you the support, confidence, lift. Coverage, I don't know, I've never done coverage, but maybe I'll just check what exactly is coverage, right? Support, confidence, lift are the three main, right? And then you have the count. Is it done? 55. So number of transactions, support and confidence. Once you're done till 55, let me know. Today all of you are going slow because we have to complete three models. I think more than three rather, because factor is very small and usually I complete association in 1 hour, under 1 hour rather, right? And it's been more than 1 hour. So can we little bit speed up? Okay. Inspect. Once you do inspect, it will give you the support, confidence, and lift. Inspect. Milk to whole, support, LHS and RHS, and the support, right? And if I, this is giving me the entire list. Now, if I view this, this is how it will look like, right? But see, lift is the most interesting metric we will be interested in, because lift means it is giving you a push, right? So I would want to sort it by lift, right? So once I do this view, I would want to sort this by lift. New grok, sort by lift in decreasing order. When I do this, let me put it. Now what has it done? It has sorted by lift. Can you see? Because lift is the factor by which your sales get increased. So this is the most crucial or the critical metric we will be, or the most important metric I will be interested in. Okay. Quickly, once you're done till 63, let me know. We We are really going slow today, so let's push a little bit, push ourselves. Let's remain out of the comfort zone, right? So lift, you can see the combination and their support, confidence and lift. View, can you share the command? V is V capital, Idris? Inspect, new grok, okay. V is capital, it's not showing anything. Strange. I will check, right? I'll have to check why is it not showing anything. Just check use view for any other thing and see if it is working. Maybe you can just do a structure of any diamond data set, right? And do a view. It should work. Maybe what you can do is just close R and open it again. It should work. I don't see any reason not working. Okay, so this is clear. Association rules is clear to all of you. There is another do-it-yourself example, which is I think the data set remains same only, right? So you can go through it, right? Okay, so let's move ahead, and now we are going to start with another very interesting algorithm called principal component analysis. Have you heard of PCA? Principal component analysis? Heard of? Okay, what is PCA, Idris? Can you, I mean, whatever you know, I'm okay. I just want to exactly use for dimensionality reduction. Very good, very good. Right? Great. So, dimensionality reduction. Yes, Alok, you're right. Great. So, let me start PCA by first discussing what is supervised and unsupervised. Okay? Because this is a very important. Um, there are two types of algorithms, right? And it's very important to understand what are supervised and what are unsupervised, right? Okay. So first, let's understand what are supervised learning algorithms and then unsupervised, right? Supervised learning algorithm models are where you have input and output variable clearly given. Let me show it to you. Regression, right? Let's take a look at the data set we were analyzing in regression. Yes, we have clearly labeled data. These are labels, variables. We have very clear labeled data, and we also have output variable, y variable, and input variable, right? Everyone with me? This is called supervised algorithm, right? Supervised machine learning algorithm or supervised machine learning technique. Now, what is unsupervised? In unsupervised learning model, only input data will be given. There is no output data. For example, we just did a priori. Was there any header? Was there any, I mean, uh, output data? Was there any output variable? No, right? Only some data was there, input variable was there, right? Unsupervised because there is no variable supervising you. Like in regression, you knew that okay, I have to predict price. It is kind of giving you some hints, right? Getting it? Supervising. In unsupervised, nothing of that sort is there. In unsupervised learning model, only input data will be given. Okay? Now, that's the process. Now, input data. Algorithms are trained using labeled data. We have seen regression. We trained, we divided into test and train, right? Train and test. And the algorithms were trained using labeled data. Correct? Right? We were training the algorithms based on labeled data. We had divided the data into train and test, right? I had clearly given you the training data and then we later on tested it, right? Now, in here, unsupervised, did we divide the data into train and test? We just did a priori, right? Or association rules. Algorithms are used against data which is not labeled. No label was there, and we did not divide it into train and test. Okay, algorithms used are, what are supervised learning algorithm? Linear logistic regression, random forest, classification trees, support vector, and neural networks. These are just handful. There are of course more, like KNN is also there, right? And naive Bayes is also there, right? So all these are supervised learning algorithm. Unsupervised can be divided into two categories. Okay, clustering, like clustering algorithm, K-means, hierarchical clustering, then also a priori, we just did association, and also which we are going to do next, that is principal component. Okay, so all these are unsupervised learning algorithms. Okay, computational complexity. Supervised learning is simpler method. Why? Because you have, at least you know the output variable. You are aware of what is going to be the output. Unsupervised learning are computationally complex. For example, clustering, right? We don't know what, how many clusters will be formed. We don't know what will be the final output, right? So that is computationally also they are complex. Use of data. Supervised learning models uses training data to learn the link between input and output. In unsupervised learning algorithm, it does not use output data, right? Does not use the dependent variable, you can say, or output data. Okay. Accuracy of results, highly accurate and trustworthy. Unsupervised, less accurate and trustworthy. Real-time algorithm learning methods take place offline because we make the algorithm learn in a training data, on training data, right? And then we test it in the on testing data, and then we deploy it in the real environment. Is that clear? Now, in unsupervised, no such thing happens, training and testing, right? Whatever is happening, it's in the live environment. The clusters are created and that's and done. Okay, so as such, nothing of that sort. Number of classes is known, right? Means you know how many input variables you are going to put, right? But in unsupervised, number of classes is not known. You don't know how many clusters will be formed, right? I never knew how many, you can say, item sets were the result of the output. Okay. Main drawback. Classifying big data can be a real challenge in supervised learning. You cannot get precise information regarding data sorting, and the output as data used in unsupervised is not labeled and not known. Is not labeled and not No, not labeled, right? Unsupervised is not labeled data, right? So you cannot get precise information regarding the data sorting. Okay, so these are broadly the differences between supervised and unsupervised, and this is the difference between supervised and unsupervised. Okay, you can see some classification, regression, SVM, all these are supervised, and clustering PCA a priori are unsupervised. And this is not the exhaustive list. It's not the exhaustive list. Okay, so let's start with principal component analysis, PCA. Okay, so PCA is a unsupervised, it's an unsupervised technique of machine learning, right? It is also known as dimensionality reduction technique, as Alok and I think who was the other one? Idris, right? Both of them mentioned it's a dimensionality reduction technique. Now, what is this dimensionality reduction? Anyone? Alok and Idris, you want to throw some light? What is dimensionality reduction? Okay, let me explain what is dimensionality reduction. Reducing the variables, very good. Reducing the number of variables, correct. Both of you are right. So let's see what is dimensionality reduction. Let me explain to all what is dimensionality reduction. See, let's say, yeah, this is a good example. Reducing number of random variables. Yeah, you're right, but reducing the independent variables, right? Then there is a reason why we do that. Okay, let's understand the reason. Correct, you're right. Now this is the same thing. I'll read through this quickly. But first, let me explain what is dimensionality reduction. Okay, let's say we'll see how our principal component. First of all, what are principal components and what is dimensionality reduction? Okay, let's say I have this variable price, right? This is my dependent variable. Y. Everyone with me, right? Price is the dependent variable, right? And I have 10 independent variables. Now this is a very small list, right? Sometimes when you run models in a live situations, right? The variables could even be running into 50 or 70, 40, 30, or maybe more, right? Okay. So let's say we have these 10 variables. So now every variable when it comes in, every significant variable, right? Every significant variable increases the complexity of the model. Yes, we have seen it increases the complexity, like this was our regression equation, right? Now if there were 10 variables, so you can see what would be the equation of the price, I mean regression line, right? 10 variables, x, y, z, a, b, c, d, E, or whatever, right? So you can see how complex that equation of line can be, regression line can be, right? 10 dimensions are there, right? So what does principal component do? Okay, before we see, what are we trying to do with by picking the ones that have higher variance? Yeah. That is what I'm going to explain in this, right? What are we trying to do by adding? Let's say I have four variables, right? And I using four variables or five variables, I had created a equation to predict the value of y, right? Now, can you tell me what will happen if instead of 4 or 5, I use 10? I will be able to capture more scenarios of y, right? More scenarios or more, I will be able to capture precisely more variance in y, isn't it? Right? More variance in y. When I say capturing more variance, if you remember in regression, what you were doing? Explained part. Remember that explained part? That is what you used to capture now. That errors, right? As we increase the number of variables, right? We are trying to capture as much variance as possible, right? Everyone with me, right? So, and if you remember in regression, there was a slide when I said, okay, let's put in four variables. We had put in AGST, then next variable, then next variable, and the R square got, there were diminishing returns, and R square got steady and stabilized. It stabilized at 0.83. Remember that slide? All of you remember that slide? And then I told you that, do you think there is a really a need for that last variable to be added? Not required, right? It was not required because the diminishing returns operated, and the R square got maximized, right, at 83, right? Now on that same line, now if suppose I had five variables, and I was using five variables, I was capturing, let's say, 70% of the variance, right? Then I added 6, 7, 8, 9, 10, and I was able to capture, let's say, 100% of, I mean, this, let's say, not 100% of variance. Let's say I was able to capture 96 and 97% of the variance, right? I was able to explain because I have used 10 model, I mean 10 variables. I was able to explain a lot of the variance, and I was able to capture it, right? Now, but you understand that how complex this model is. It has 10 variables, right? Or let's say we bring in more variables and we increase it to 20, 25 variables, right? Now, what happens with what you do with principal component is you try to create, instead of using 10 variables, I create principal components, right? Instead of using these 10 variables, I will use only 3 or 4 principal components. These are called principal components. Each principal component is going to be a combination, right, of all these 10 variables with some weights. Okay? Are you getting this? Right? So, after using 10 variables, I was able to capture 97% of the variance, right? And I will create some principal components. Now, this is all done at the back end, right? You don't have to do it, but yeah, this is what is done. So I'm just explaining. It will automatically create some principal components. The algorithm will create some principal components called, first we call it PC1. It will automatically give some weights to each of these independent variables, and with this first PCA, I'm able to capture 70% of the variance. Then I created a second PCA. Again, there were some weights I had to put with these 10 independent variables, and PCA2 was created. It another captured another 20% of the variance, right? So 90% already captured using two PCAs, and then it will come up with another third variable again, which is a combination of these 10 independent variables, and it will capture another 5%. So in all, Using 3, I was able to capture 90% of the variance. Do you really think if I'm able to create 3 variables which are a combination of these 10, right? Won't that now, and this is all done at the back end. I don't have to do it manually, right? Do you think I would really want to create a equation with 10 variables if I can manage it with just 3 and a little bit of difference? Here 97 and here let's say 93 also it will do, right? Let's say the third we are able to capture 93, 3% only. Do you think, which one do you think is more efficient? The second option, right? Because I have simplified my model to a very, to a large extent. I'm just using 3 variables, right? And there I'm using 10 variables. Are you getting it? So that is what PCA does. We try to model the variation in Y based on the variation in X, right? So based on the variation in X variables, we try to model and capture the variation in Y variable. Model the change in Y based on the change in X, basically, right? So based on the changes in X, what is the variation you can capture? How much variation you are able to capture in Y? These principal components help in capturing these variance. Is that clear? Is this clear? What is done with PCA? What is done in PCA? Yes? The concept is clear? Let's quickly. Now, another interesting thing is, remember the multicollinearity, right? Now, these principal components that are formed, right? They are orthogonal. Orthogonal means they are they do not have any multicollinearity, right? They are usually orthogonal means they are at a the components are formed. They are at a they at a 90 degrees usually. So it is going in this direction. Some one is going in this direction. The third one will be probably going in the upper direction in the the third dimension. Okay, and they try to capture as much variance as possible in the space. Okay, so is PCA is a dimensionality reduction technique. Everyone got it? What is dimensionality reduction? Why it is called dimensionality reduction? Can you quickly respond? I don't want to wait. Okay, thanks. PCA is a method of obtaining important variables. So it is extracting the important components, right? Or important elements from the variables, from the independent variables, right? Is a method of obtaining important variables in the form of components from a large set of variables available in the data set. Okay, a principal component is a normalized linear combination of the original predictors in the data set. I've already shared this. Already discussed this, right? They are also called summary variables, which are not correlated to each other. I just told you. They are not correlated means they are orthogonal, right? Because because if principal components we are creating it, correlation would not come. Of course, it will not come because we try to capture uniqueness. Each variable will be unique. It will not capture any duplicate data. Okay, it will not capture any duplicate thing. Okay, so principal components try to capture maximum variance within themselves, need not be all. PCA reduces the dimensionality and redundancy by combining original variables in a way that captures the maximum variance, right? It reduces redundancy also, means if there was any multicollinearity, if there was any duplicacy, it will remove that. Okay, is this clear? Principal component, I'll read through this and then we will go to R. I think post the break we'll go to R. Okay, quickly read through this. PCA is a tool that has two main purposes: to find the variability in the data set and to reduce the dimensions of the data set. To find or capture the maximum variability in the data set and reduce the dimensions of the data. Reducing dimensions means that redundancy in the data is eliminated, right? It can make patterns in the data set more clear. Therefore, principal component analysis is a good tool to use if you suspect you have redundancy in the data. Redundancy does not mean that the variables are identical. It means that there is a strong correlation between them, multicollinearity only, right? Principal component analysis reduces dimensions by projecting the whole data set onto a complete separate space. Now, it has, see, PCA does not, uh, is not in PCA1, PCA, sorry, PC1, PC2, PC3 are all together in a very different space, right? It is not in any of the plane from x1 to x10. It is all together in a different space. Okay, that is what it is saying. Transform into new set of artificial ones which are, okay, sorry, onto a completely separate space. The original variables are transformed into new set of artificial ones. Of course, they are artificial because they were not the original variables. We have combined the variables and formed some new components, which are the principal components of principal component analysis. These components can be extremely useful as criterion variables or predictor variables in the later data analysis. Reducing the number of variables of the set of data set naturally comes at the expense of accuracy. Of course, you can see I discussed this, right? Of course, I'll not be able to capture 97% of the variability, but I'm okay with 93% because I am choosing simplicity over accuracy. Okay, it comes at a cost of accuracy, but the trick is dimensionality reduction is to trade a little bit of accuracy for simplicity, because smaller data sets are easier to explore and visualize, and making analysis, or sorry, make analyzing data much easier and faster for machine learning algorithms without extraneous variables to process. Is this clear? Is this clear, principal component? Everyone, can I have some more response? Now this is just that when first principal component came in, it captured 40%. Second principal component came in, it added another 20%, then another 10%. So three principal component captured 70%, then another, and so on. So this is, you can see, diminishing returns are operating kind of, right? Okay, concept is clear, principal component. So let's go for a break. We'll take a 17 minutes break, and I'm opening the poll. Please do participate in the poll. Let us know how did you do in terms of pace and delivery. And when we come back, we will continue with the principal component example. We'll continue in R and with the principal component. Please do participate in the poll. I am also creating a timer for you to follow, and timer is created for 17 minutes. Okay. Hello, everyone. Thank you so much for participating in the poll. Please give me a confirmation if I'm audible to all of you. Am I audible? Idris, Alok, Vishal, Pungodi. Am I audible? Amatullah. Audible? Thanks for the response. Am I audible to others? Okay, Idris has responded. Alok has responded. Pungodi has responded. Good. Three responses are good. Thanks. Thank you so much for participating in the poll and appreciate your participation. And so let's continue, right? So we have seen principal component analysis, reducing the dimensions and simplifying the model. Okay. So what we'll do is this is a very, I mean, we're going to do principal component analysis for a very small data set is iris. All of you know iris? Yes, we know iris. Yes. Okay. One small thing for principal component, and I would assume that logically you would have guessed it. I mean, you would have noticed it. But yeah, still it's worth mentioning that when I'm saying I'm creating principal component here, right? I am creating principal components which are a combination of these 10 or more than 10 or independent variables. So that means, I mean, because I'm creating equations here, right, that means all these are going to be numeric. Getting it? So principal component can be created, can be done when you have numeric variables as independent variables, right? And it's very much evident also here, right? Everyone? Okay. So iris data, let's view this data. Iris, structure summary, we all know. Quickly run through structure summary. So you'll notice structure, if I see the structure, 150 observations across 5 variables, 4 of them are numeric, right? And the fifth one is, so I'm going to drop this anyways. The fifth one is the dependent variable for me that I want to predict, right? So I'm going to just drop it. So I will drop the fifth one. Once you run structure summary, let's drop this fifth one. In line number 14, I'm saying create a df, create a variable df, which will be equal to iris minus the fifth variable, right? Minus the fifth column. So now when you see df, head of df, you can see it's only 4 numeric variables. Okay, quickly do this. Till line number 15 you have to do. Line number 15.
Once you're done, let me know.
Okay. Others, can I get couple of more confirmations? Am I audible? Am I audible? I don't know. There was, yeah, yeah. Just hold on. There was some, I don't know what happened. Some technical glitch, and my internet got disconnected. So just give me a minute. Uh, I'll just get this presenter rights, right? Just give me a minute. Yeah, yeah. I'm just getting the presenter rights. Okay. So where we were, right? So if you see, we already had four variables, right? And with just two principal components, I'm able to capture 95%. Isn't it? Right? So, makes sense that we take only two of them, right? So, cumulative proportion says that component 1 I mean, this is what I've already explained, right? In general, considers components that reflect 85% or more, right? That this is just a, you can say, rule of, I mean, thumb rule, right? If you have if you have been able to capture 85% of the data, then it's good, right? Okay, so now I can plot this line and you'll see this variance in terms of variance it is capturing. First principal component, then second principal component, third, and so on, right? So now attributes, it is just going, if you run attributes, it will give you the attributes, I mean, what all the names of variables that are there in the output. Okay, then by plot, it gives you the by plot which how these principal components are formed, right? What all, how these, I mean, of these four principles, you can see component 1, component 2, right? And how these principal components are formed. This biplot shows you that. Orthogonal, you can see four orthogonal variables, right? So this is the biplot. Run through this and then I'll explain loadings. Loadings, if I run PC $loadings, you'll see it is basically loadings is the weight. Each principal component 1 is created using these loadings 3 and 4 for these. So that the weight I have given to x1, x2 while forming the equation, that is loadings give you the, it represents the correlation between the components and the original variable. These are the values, or you can say weights, with which we form the equations of the PC. Is that clear? So this is principal component 1 is created with these weights or loadings. We call them loadings. Okay? Is that clear? Now, as I said, since the first two components are explaining 95% of the variance, we need not include all the variables in the model. This is how we can cut down the variables. Now, SS loading is sum of squares of the loadings, right? Sum of squares of the loadings, not much used in taking any decision, but this is additional they have given, right? Not much used in taking any decision. Now, scores. Remember I told you we put scores is equal to true. This is going to give me, if I write, okay, first you do it till 37. Please do it till 37. Sorry. Once you're done till 37, let me know. Once you're done till 37, do let me know. I'm waiting. Okay, great. So next is scores. Now scores are just the replacement values using principal components. What are the 150 values, right? Four principal components. How these four principal components are, I mean, you have transformed them, right? Using principal components, how do you arrive at first record, then second record, right? Again, this is just additional information, but not used in finalizing the model. Okay, the finalizing the model is done using these weights and then the cumulative variance. Why are we seeing only cumulative variance and not proportion variance? Um, See, ideally, I will not look at here also. I will look at, okay, here. See, proportion of variance is actually what is cumulative. I'm adding proportion of variance now. So it's the same thing. The ultimate thing is cumulative is giving me an additional information total. Now here you will have to do the total. So cumulative is just giving you one step ahead. Okay, right? So cumulative is derived from this only, right? Okay, so that's yeah. So that is principal component. And now next we are going to do is factor analysis, right? Factor analysis is another. Uh, Let me open. Yeah, that same. What is factor analysis? It's another unsupervised technique, unsupervised machine learning algorithm. Again, it is a dimensionality reduction technique, right? And very similar to principal component. It is similar to principal component, but there is a difference, right? We'll see that. Factor analysis create factors from the observed variables, right? See, here we name it as factors from the observed variables to represent the common variance, that is variance due to correlation among the observed variables, right? So basically, what do we do? Factor analysis is done to create the factor analysis create the factors from the observed variables that were there to represent the common variance. What is the variance? How much variance these factors can be clubbed to capture, right? The goal of factor analysis is to describe the variability among correlated variables in fewer variables called factors, right? So here the goal is slightly different. There the goal was to capture maximum variance. Here the goal is to capture the variability that is coming from correlated variables, right? In fewer variables called factors. So we are going to capture the variability represented by multicollinearity. Remember, we are going to capture the variability. So what we are going to do here is we are going to club together the variables that are highly correlated. Okay, so that we are able to capture the similar amount of variance using less number of variables. Are you getting the difference? There, my only aim was capture maximum variance, but reduce the number of variables. Here also, I am reducing the number of variables, but the intent is to club the variables that are highly correlated. Getting it? And we call them as factors. Club them and call them as factors. I'll give you an example. It will, make things very clear in the next slide. Okay. It is based on the idea that some latent factor exists which can be described, which can describe multiple variables. For example, let me see. These are factors. Now, these were my observed variables, right? Waiting time, cleanliness, and staff behavior, right? Then taste of food, food temperature, and freshness of food, right? I club them. Now, these look highly correlated, right? Taste of food, temperature of food, I mean, whether it is warm or not, and the freshness of food. Don't you think the sales in a restaurant is going to be very dependent on these three factors? And taste of food, I mean the warmth or the temperature and the freshness they are also highly correlated. Yes. So I put them in a single variable called food quality. Right. Similarly, waiting time, cleanliness, and staff behavior. They are I mean, though it is written cleanliness, but we can probably put it on maybe some other uh, factor name we can give. I don't think cleanliness and staff behavior, I mean, waiting time and staff behavior won't go with cleanliness. I can put another name here. Let's say uh, waiting time, cleanliness, hygiene, right? Some hygiene you can say, right? For a restaurant, it's like hygiene, right? How much waiting time is going for in a restaurant? How much is the cleanliness and staff behavior, right? You can call it as hygiene rather than cleanliness. Okay, so these are again some some amount of correlation definitely they have, right? So these are called factors. So what I have done ultimately, I am doing the same thing, but the logic is different. There I was capturing, my purpose was to create some principal components which were completely different from the existing variables. Here I am creating factors which, by clubbing the variables that are highly correlated, multicollinearity, I am just trying to reduce the multicollinearity to zero, to as low as possible. Okay, factor, is that clear? The logic between both of them is clear. The difference, everyone, I get response only from 2 or 3 people. Yes, thank you. Thanks for response. I'll keep on pushing you to respond. Okay. Okay. So factor analysis is a statistical method used to describe variability among observed correlated variables in terms of potentially lower number of unobserved variables called factors. Right? Right? For example, it is possible that variation of 6 observed variables mainly reflect the variation in 2 unobserved underlying variables that I have just explained you in the next slide, right? Factor analysis searches for such joint variations in response to unobserved latent variables. The observed variables are modeled as linear combination of potential factors plus error terms. Factor analysis aims to find independent latent variables. Independent latent variables means among these two, there will be they would be independent, means there would not be any amount of correlation between these two factors. Okay, clear? What does factor analysis try to do? Right? So let's go to R, and again I'm trying to, we will work on iris. These are very, both PCA and factor, they are like very, you can say, small in terms of content, not in terms of importance. Of course, they both are important, but in terms of content and understanding concept, they are small or easy to understand rather, right? Okay, so data iris, again, view, let's view iris, dropping the fifth one, again, I will drop the fifth one, and just as simple as this. These are all the same, right? View, head. I'm just dropping the fifth and viewing and fine. Then factor is simply created. Factor analysis is done by the command factanal. Now factors equal to 1 means I'm asking R to create one factor only, right? If I, how many factors you want to create basically, right? So even if now, since we have only four variables, even if I want to create two factors, it will not create two factors, it will only create a single factor. So if I just run this, it has created only one factor, right? And these are the loadings, uniqueness of each factor, I mean uniqueness of uh, in in the factor. What is the uniqueness of each variable? So you can see sepal width has the maximum uniqueness, and these are loadings that led to creation of the factor. So very similar, you can see SS loadings and proportion of variance. So with one factor, I was able to capture 72% of the variance. Okay, once you do till 76, let me know. Okay, let me quickly read through this. To create the factors, function used is factorial. This is okay. Even if we mention factors equal to true, the model will not be able to give two factors as the data set is too small. Okay, then factor, this fact, when I run this 76, this is the output I get, right? First, it tells the uniqueness. Uniqueness tells you how much is the contribution of each in the factor, right? How much is the variation does that the column has? Okay, how much is the variation each column has? How much uniqueness is contributed by each variable? SS loading, we have seen sum of squares of loading. There you go. Now, here there is a point. Uh, if SS loading of this factor is greater than 1, then only this factor is worth keeping. Okay, you just have to remember this. If the SS loading is greater than 1, it is worth keeping. Proportion of variance, total variance that has been captured, we've already seen this earlier also, right? So when you have multiple factors, you can select the factors based on proportion, of course. Here only one factor is there. So I mean, you'll see it has a lot of similarity in terms of selecting variables also, uh, vis-a-vis the PCA. It has the same similarities, right? And that's it, right? So, and last, yeah, it tests the hypothesis that one factor is sufficient enough. It is testing if one factor is sufficient enough in capturing the uh, variance, right? So it is doing a hypothesis of that, and the p-value comes out to be very low, right? So it's in the rejection region. Okay, so that's factor analysis. Okay, is it done? 83 till, yeah, 83 is just a small command. You have done till 76, right? Right? Okay. Next. Okay, so we have done regression now, right? Now what we are going to do is classification, right? So to start with classification, what we'll do is we will uh, start with some simple classification regression models like naive-Bayes, SVM, and then we'll move on to logistic tomorrow, right? Logistic will is a long one, so it will take, I think, 2.5 hours tomorrow, right? But we'll first understand what classification is, how is it different from regression, and then what are the different types of classification models we are going to learn. Okay, classification. First, let's understand what is classification, right? With the help of an example, bank loan example. A bank has to analyze if loan should be granted to all its customers, right? It has to analyze whether the bank should be giving loan to its customer or not, right? There's a lot of variables. Remember, I discussed this example earlier also, that when you go to a bank, it is not randomly they are asking you some data. There is a logic, there is a scientific reason behind why they are asking you that particular data, right? So when you go to a bank to take a loan, or let's say maybe get a credit card, or any other product, right? They ask you about age, employment status, income, etc. Yes, they ask you, right? Now, when they have taken this, right? Historically, they have been capturing this data for thousands and thousands of customers, right? Or even lakhs or millions of customers, right? Now, what is their dependent variable? Whether to give loan or not to give loan. That is the dependent variable, right? So that's a Boolean. Yeah, it's a decision. It's not a numeric variable, it's a Boolean variable. Yes or no, right? How the bank comes to this process, right? How the bank arrives at the decision whether to give loan or not, right? They can, there are various classification algorithm, and why this is called classification, because your dependent variable, we are just classifying the records, or we are just classifying our, in this case, customers into some categories, right? Should be given loan, should not be given loan. That is why this is called, this the process with which bank, or the process with which the this algorithm happens. This is called classification algorithms. Okay, and decision tree is one of the most used classification algorithm. We are going to do decision tree tomorrow or day after. I think day after. We have, after today we have 3 more sessions, right? 3 more sessions, right? Yes. So we'll do decision tree day after. Tomorrow we are going to do logistic, right? The bank, now with the help of decision tree, this is just one of the classification algorithm, not always with the help of decision tree. The bank decides if a customer should be granted loan or not. Now this thing can happen with the help of logistic also. It can use, bank can use various other algorithms, not just decision tree only. Okay. What is classification? It's a technique to determine the extent to which a data sample will or will not be part of category or type. Okay. The data sample, whether it will be part of it or not part of it, we can decide with the help of classification algorithm. Classification models predict categorical class labels. Yes, to give loan. I am giving loan, not giving loan. The health, subs, uh, based on some parameters, health parameters. The person is going to have cancer or diabetes. The person is not going to have diabetes or cancer, whatever, right? The, in terms of telecom, the person will move out, the subscriber will move out, the subscriber will not move out. In terms of classification of mails, this is a spam, this is a ham, right? What else? Where can you use classification? The person is going to buy, looking at the parameters, looking at the is trail record. The person is going to buy on this website. The person is going to not buy on this website. Getting it? Right? He is going to default on credit card. He is not going to default on credit card. Right? So all these are categorical class labels. Okay? Is this clear? The classification process includes the following techniques for prediction. First, it constructs the model and then it uses the model. Obvious. Model construction, it is done to describe a set of predetermined classes, right? Every sample belongs to a predefined class. The model is represented as decision tree, classification rule, or mathematical formula, and need not be just decision tree. It can have classification rules. It can be logistic as well, right? Now this is a very limited statement to make. Okay, it does not classify unknown model usage. It does not. It is done to classify unknown or future objects and to estimate the accuracy of the model. Now, once the model is created, we try to classify them, right? We try to check the, not classify, we try to check the accuracy of the model. Okay, the accuracy rate is the percentage of the test set samples correctly classified by the model. Okay, that is the accuracy rate. Now, how much the model is able to uh, predict correctly, right, based on the test data, that will help me in deciding the accuracy of the model. Okay, in case of acceptable accuracy, the model is used for classifying data samples with unknown class labels. Means unknown data. It will help you in uh, identifying or getting the accuracy. Okay, now let's see this classification with the help of an example. Now, how does classification models work, right? Model construction. How is the model created? Let's see. It creates classification. Mostly, it creates rules, right? And those rules are based on analysis of the training data, right? For example, this is my training data. It has names Mike, Bill, Dave, and Anne. Now, based on rank and years, it is classifying the professor as tenured or not tenured. If it is an assistant professor, Mike is an assistant professor with 6 years of experience, it has classified him as not tenured, right? Bill is an assistant professor with 7 years of experience, so it has classified Bill as tenured. Dave is an assistant professor with 3 years of experience, right? So it has classified, it has, the model has, classified Dave as not tenured. And Anne is a professor with 2 years of experience. The model classified it as tenured, right? So now a classification, when algorithm is going to study this or going to analyze this data, it is going to come up with some rules. And this is the rule that it has come up. If the rank is professor or years are greater than 6, is that okay? If the rank is professor or the years are greater than 6, then we classify the professor as tenured. Then tenured is equal to yes. In other case, right? Yeah, right? So this is the rule it has created based on the this small data. Okay. Now when new data comes in, right? Let's say this is the testing. Now we are testing it, right? Based on the rules, year 7, so tenured. Years 2, an assistant professor, not tenured. Assistant professor and 7 years, it says no. Now, as per this rule, this should be yes. Yes, right? So this is one wrong classification it has made. This is a wrong classification model has made. And then George, who is a professor with 5 years of experience, it has classified as tenured. Again, it has classified correctly, right? So this is a testing data. And how do you measure the accuracy of this data? Of this. See, one was classified wrongly, right? Rest three were classified correctly. So accuracy is 75%, right? That's how you calculate accuracy. Now, when unseen data comes in, Jeff, who is a professor with 4 years, so what should it classify as? Tenured, right? So this is just a very small example how classification is done. Now, what we'll do is we'll start with, okay, we'll start with logistic only, right? We are going to start with logistic, and I think we'll do the concept part of logistic today. And tomorrow we'll do the logistic on R, because there's a reason I'm starting with logistic. So we'll start with logistic today. And decision tree random we'll do day after tomorrow, and all these we are going to do tomorrow then. Right, perfect. Okay, logistic, coming to logistic regression. Let's start with logistic. For logistic, I'll start with logistic. Okay, anybody of you who has heard of logistic earlier? What does logistic do? Anyone? Anyone who knows what is logistic regression? Heard of? A simple linear regression? No. Use binary classification? Correct. Amatullah, why simple linear regression? Why are you saying simple linear regression? We have done simple linear, no? Yes. So why will you say logistic as simple linear regression? Okay, it's not simple linear regression. We'll understand the difference and then we will continue. Okay. So all of you know regression, right? We have discussed this, right? Based on some independent variables, we try to predict a dependent variable. So, okay. No, Amatullah, independent. I never said there's only one independent variable in logistic. Who said that? I never said that. There's only one independent variable, right? Okay. Now, look at the difference. What are the different types of regression and why is logistic a special category of regression, right? Means, uh, see, regression, we know regression now very well, right? So, regression, we are predicting a variable that is numeric or continuous, right? For example, we were predicting price, right? So, and there can be two type of regressions. Uh, I mean, linear regression and polynomial regression. The only difference between them is linear is a single line, polynomial is a higher degree regression lines, right? Square or cube or maybe four, right? Higher degree regression lines. Okay. So in linear regression, whether it is simple linear or multiple linear, we establish a relationship between dependent and independent variables, right? In polynomial, it establishes a relationship of a non-linear relationship rather. It establishes a non-linear relationship between dependent and independent variable. Clear? Now, what is the special thing about logistic regression? It is used when the dependent variable is categorical. Bank loan example. All those examples that I gave, whether the person will buy on the website or not, whether the subscriber will leave my network or not, whether the person will have diabetes or cancer or not, right? Whether the person is going to uh, run a marathon or not, right? All these real time decisions, right? They notice that the dependent variable in all of them is a categorical variable, right? Something in the nature of true or false, yes, no, 0, 1, Boolean nature basically, right? And all now this is the main difference between logistic and in linear. Remember this. In logistic, the dependent variable is categorical. In linear, it is continuous, right? And this is how the graph of logistic looks like. We are going to discuss this. First, let's understand the logistic regression better. Logistic regression seeks to model the probability of an event occurring depending on the values of independent variables. Yes, sigmoid, correct, right? Now logistic regression, what does it do? It models the probability of an event occurring depending on the values of independent variables, which can both be categorical or numeric. So what is it saying? The input variable can be categorical or numeric, but the output variable or the dependent variable is always categorical. Now, using those different types of input variables, we try to model the probability. right? So what is the probability we try to come up, we come up rather, not try to, we come up with the probability that the person is going to default. The person is going to have diabetes. The person is going to leave network. We come up with the probability of these events. And if that probability is greater than the threshold, right, which is usually 0.5, right? If the probability, if let's say the probability that a person is going to leave network is 0.7, which is greater than 0.5, right? So we will classify the person as classify in the person in as in a in a leaving category, right? Is that okay? Is that okay? Right? So estimate, model the probability, right? Estimate the probability that an event occurs for a randomly selected observations versus the probability that the event does not occur. It estimates the probability. First it models, then estimates, then predict the effect of the series of variables on a binary or response variable, binary response variable. Okay, then it predicts based on that probability as I just discussed. We try to predict. Okay, the person is going to have diabetes. The person is going to run marathon, right? All these classifies the observation by estimating the probability that an observation is in a particular category of dependent variable. For example, true, false, approve, not approve, etc. And lastly, it uses the used to classify binary classification problems. So it is used to classify binary classification problems like 1-0, win lose, pass fail, healthy sick, etc. So logistic is used only for when the dependent variable is can be classified into can dependent variable is categorical. Okay. Examples already discussed: simple linear, multiple linear, then logistic. Dependent variable is one only and categorical. Independent variable can be two or more. They can be continuous or categorical. Relationship between these variables need not be linear. I mean, relationship between dependent and independent need not be linear. Examples: ham spam, not spam, loan given, student passing or failing, customer takes offer or not take offer, etc. Some more examples: credit scoring, logistic regression helps in regression is widely used and acceptable technique in credit scoring. Banks collect the data for a person who comes to get the loan. Their analytics team try to analyze the data collected, and the data scientists try to predict if the bank should give the loan. We have already discussed this, right? Bank example, medical, the person will have diabetes or not, hotel booking, the person is going to book the hotel or not, right? Then telecom subscriber, whether the subscriber will leave the network or not, based on subscriber bill amount, usage, number of complaints in the past he has made, number of years the subscriber is with network, location, services taken, etc. Is this clear? Now let's understand how do we what is the procedure behind the logistic? Well, how do we come up with uh, probabilities, right? For each event. For each event, we come up with probabilities. So let's understand how do we come up with probabilities. So coming up with probabilities require you to transform your linear model. This is a linear model, right? Linear regression line. Transform this to a logistic model, right? Wherein, so I will transition from a linear model to a logistic model. Okay. Now let's look at the first picture. See, I have only two outputs, yes or no, right? Either diabetes will patient will have diabetes or no. Subscriber will leave or not. Bank will give customer loan or not. So I have only two options, right? So if I try to plot these options 0 and 1 on 0 and 1 on y-axis, this is how I'm going to plot in this first case. Look at this. This is all I can plot, right? I cannot have any data point in between because it's either yes or no. It's either 1 or 0, right? Yes? Everyone with me? Right? So now if I try to pass a linear regression, if I try to pass a line from this data, can I pass the line? Can it give me the trend? No, not possible, right? So what we do is if I clip this line from here, I clip this line, and from here I clip this line, right? If I clip this line, it will still be able to model, right? When I clip this line and I smoothen the edges, it forms this S-shaped curve, right? This S-shaped curve is called sigmoid. This is called sigmoid function. Okay. Now, how does this approximate to sigmoid? We'll see. As we create a scatter plot, the dependent categorical variable y can take up either 0 or 1. The linear model does not fit appropriately in such a dichotomous data. Made to fit by clipping the ends to cover the data points. But such a line cannot be formed into a single formula. Isn't it? This line, if I clip them, they are basically three lines. One, if I clip them, it is basically three lines. 1, 2, and 3. Right? Is this clear? Three lines. Right? So I cannot have a single formula. Smoothening the edges of the clipped line create a S-shaped curve which can be formulated into a sigmoid function, which is this. It's a sigmoid function. Sigmoid function can model such a scatter plot. Now, if this is my scatter plot, sigmoid function can still model it. Okay. Now, how do we take a decision based on sigmoid function, right? So, if this is my sigmoid function, right, I create a decision boundary in between. For like here, I have created a decision boundary. Now see, when I create a sigmoid function, right, notice that here I have probabilities. Yes, yes, you can see probabilities here, right? So now what happens is, with the help of decision boundary, see these, when your data point is closer to 0, right? The and these data points are closer, or in fact they are equal to 1. But the issue or the decision that I have to take is when your data points lie on, is this clear, right? Now if I take the decision boundary as 0.5, right, means now in between this point and this point my probability is going to be there, because uh, before this it's 0, after this it's 1. So in between my probability will vary from 0 to 1, right? And I am going to get the probabilities of every data point or of every record in my data, and I am going to compare that probability with my decision boundary. Suppose the probability of uh, probability from the logistic model that the person is going to leave the network, right, comes out to be zero point 0.6, right? So the person is going to leave the network. The probability comes to be zero point 0.6. Okay. So I'm going to compare zero point 0.6 with zero point 0.5 and take a decision. If it is greater than zero point 0.5, I'll put it here, left, and if it is less than zero point 0.5, I'll club it here. Okay. Clear? So when my data point has a probability here, actually it will have, right, it's going to fall from here to here. Uh, Idris, it's very normal. It is a business decision, right? It's a very business decision. If it is equal to, now it is not that every time you take the decision boundary as zero point 0.5 only. If you want to be more stringent, right, you can take the decision boundary even as zero point 0.4, right? So any data point greater than zero point 0.4 will be clubbed as A category, otherwise it will be clubbed as B category. So it all depends. It is a business decision where to take the decision boundary. Okay, right? So notice that all these data points, see the data points that you see here, these are all having 0 probability, and these are having 1 probability. But the data points that start from here till here, these are the ones, and these are the ones. They were on this, you can say on this line, and based on the decision boundary, either I have classified them as 0 or classified them as 1. So they are lying here. Is this clear? Okay. So let's quickly see how sigmoid helps us in taking decision. The main reason why we use sigmoid function is because it exists between 0 and 1. First reason. Why do we use sigmoid as as function? Because it lies between 0 and 1. So whenever we are calculating the probability for an event, whether it is happening or not, so sigmoid becomes the obvious choice, right? Now, therefore, it is specially used for machine learning models where we have to predict the probability of an outcome or output. Since probability of anything exists between 0 and 1, sigmoid is the right choice. Now, if t is greater than output, sorry, P is greater than 0.5, the output marked is true. If P is less than 0.5, the output marked is 0 or false, right? That is what I've explained. Now, how does this regression line transforms into, uh, or rather, how does this sigmoid uh, transforms into this uh, probability? How does this sigmoid transforms it into probability? That is, for understanding how sigmoid is, you can say approximates rather probability, we need to understand that understand something called the odds ratio, right? So odds ratio is the ratio of probability of success divided by probability of failure, right? So odd ratio, if there is only there are two outcomes, success and failure, odd ratio will be P upon 1 minus P. Is this clear? This is called odds ratio, right? Now, when and these are some examples, right? You can go through these examples, but more or less, the top line is that odd ratio is simply the probability of success divided by probability of failure. Okay. Now, so this is how the odds ratio is calculated, right? This is simple. Now, odds ratio in logistic regression. The odds ratio for an independent variable in logistic regression represents how the odds change with 1 unit increase in the independent variable, 1 unit increase in the independent variable holding all others variable constant, right? That is the odds ratio in the logistic regression. The odds ratio represents the constant effect of a predictor variable X on the likelihood that one outcome will occur. Okay, and so these are just examples of odd ratio. Now, how does odd ratio transforms or approximates or converts into sigmoid, right? See, this is my odd ratio, right? When I take a log of odd ratio, ln, this is not in, this is ln, right? I convert this taking log of, this is ln means log natural, log to the base e, right? When I pass the log on both the sides, right? Also called, this is also called the logit function. Okay, note that log of this is called logit function, and this function, logit function, is plotted as this, right? This is the logit function. So plotting the logit function for p equal to 0, if I plot p equal to 0, right, the value of logit is log natural 0, which is actually infinity. You don't have to learn this. I mean, you don't have to anyways remember this. Okay, this is just, I'm explaining what happens at the back end, right? So from those odds ratio, you create a log by doing a log natural, you convert it into a logit function, and when you inverse this, it turns into a sigmoid function, right? This is the inversing, logit inverse, right? Logit inverse. It becomes a sigmoid function, right? So that is why we use sigmoid, because sigmoid function can be easily approximated to measure the or to represent the probabilities. Okay, so in logit, in the logit function, 0 and 1, that is the region of probability, ran across x-axis, right? You can see 0 to 1 running across x-axis, but we want the probabilities to appear on y-axis. So probabilities to appear on the y-axis, we can do so by taking inverse of logit function that I've already explained. Inverse of logit function is also called sigmoid function. So here, if you see, I am just doing a inverse of this, and right. So this is all the transformation of from uh, probability to logit function. Okay. So this is, I've already discussed this. The main reason why we use logit function is because it exists between 0 and 1, right? So that's the, and this is sigmoid transformation. I mean, not required, but I've given it. If you are really interested in the mathematics behind it, you can go through it. Otherwise, not required for data science. Okay, so that is all we have in the. Is it because of this logistic? It is because of this logistic. Is it? Yes, it is known because of this logit. It is known as logistic. You mean to say that, right? Logit. It is, that is why it is known as logistic. Correct. Right. So this is all, but you don't have to. As I said, though I have discussed it, just I have discussed that there is a transformation that happens at the back end. Why do we approximate the probabilities that we'll get from the model, right? How do we take decision, and how do we approximate these probabilities into a sigmoid function, right? So on that note, what we'll do is we'll take a pause, and tomorrow we are going to start with the logistic regression in R, and we will complete that, and we will do some more models like naive Bayes and SVM, right? So we will complete those models then. Okay, then thank you so much. On that note, we'll continue tomorrow with logistic. Okay, till then, take care. Goodbye.
Thank you for a wonderful session, Deepak, and thank you everyone for your participation. Once we wrap up the session, you will it will lead you to a survey feedback form. If you like the session, please rate us a 5. For anything less than 5, please share your comments and help us understand what went wrong. It will help us improve in the upcoming session. Thank you all for your time. Take care. Good night.